population mean we belong to the interval with 95% confidence. Okay, so for the confident interval, we will find the lower limits confident and upper point. And for the point estimate of the sample, it will belong to the confident interval. So now we show how to compute interval estimate of a population mean V and P, right? Mean for population is denoted by V and proportion for population is denoted by P. In order to develop an interval estimate of population mean, the population standard deviation sigma must be used to compute. So in most applications, sigma is not known. So for this lecture, we will focus on three main cases. The first one, estimate the mean when you know the standard deviation of population. You can estimate the confidence interval of the population mean when the standard deviation of population is unknown. And for the last one, we will use the proportion of sample to estimate for proportion of the population. Okay. Okay, so here's some steps to show the confidence interval for population mean for the first case, for the first trend here. See? This is the first case. For the first step, you have to check the assumption. The population standard deviation is not known. I mean, you have to know, you have to get the value for sigma is have equal to 3.5 or what. So you have to show, you know the information about the population standard deviation. For the second step, you have to sure that your population is normally distributed, or if the population is not normal, so you can apply CLT. Do you remember CLT class? What is this?
Central limit theorem.
Yes, you can apply the central limit theorem because for this theorem, it's said that when your samples is greater or equal to 30, the sampling distribution of sample mean will be nearly or approximately normal. You can check. Okay, so after that you can find the confidence interval estimate for population mean by using the formula. Okay, so you can see that it's have the form H bar. Here is the point estimate, the point estimate plus or minus marginal error, which denoted by ME, marginal errors. Okay, plus or minus. So it will help you to define the interval. This is a lower limit, and this is the upper point. So in here, let's see what we have in this formula. The first one, H bar. What is this class? H bar. H bar, what does it mean? Yes, the sample mean. Okay, for the second one, we will skip that one so I can explain this for the next line. Because in this case, we know the standard deviation of a population, standard deviation known. So we know that values, right? And after that, the square root of n. So the values of n in here and letter n. What does it mean? The sample size, okay. Only two in my class. Okay. So actually, in here we learn the way to find the values of these of alpha over 2. So alpha over 2 satisfies that probabilities of these greater than the alpha over 2 equal alpha over 2. Okay, do you remember the probabilities for z? Is this the probabilities or is this the areas for the standard normal distribution, right? Z for standard normal distribution, Z. And in here, probabilities are the areas when Z is greater than Z alpha over 2. Here is that values in the horizontal line. So that areas in the right hand side, the areas in the right hand side have equal exactly alpha over 2. This is the areas. See? So right now we will define the values of alpha. What does it mean? Okay? Actually, the proof of the confidence intervals formulas is optional. Okay? So we can start with the sampling distribution of the sample mean. Recall that is under some conditions. So this distribution is normal or approximately normal. So after that, you have to convert it into standard normal distribution. Here is a shape, so you can see that the areas is still there, but the values of when you convert from the normal distribution into standard normal distribution is a little bit different, right? Because in here the midpoint is maybe any value that you can find. But for the standard normal distribution, the mean equal the mode equal the median is have equal exactly how much? For standard normal distribution, the values in the midpoint we equal how much? Class, for the standard normal distribution. Okay, thank you, Thu Hương. Is equal exactly 0. So when you look at the figures in here, Z answers is the Z values such that the areas to its right is equal to alpha over 2. So because it's for the standard normal distribution, it is bell shaped and it is symmetrically, right? So for the area, the stated reason in the left hand side is equal alpha over 2, right? So can you help me to calculate the areas for the right reason? What is the areas or the probabilities when these belong to the interval from minus z alpha over 2 to z alpha over 2? What is the areas or what is the probability for the y reason? Okay, thank you, Ngọc Diệp. Because alpha over 2 in both sides, right? So you know that the areas under the curve equal 1, so the areas or the probabilities for the y reason will be 1 minus alpha. Okay, so these formulas will show you the way to convert from normal distribution into the standard normal distribution, right? Convert from the H bar to Z to U the table, right? Okay, so this slide will show you the meaningful answer. The confidence level or is denoted by 1 minus answer. The confidence level is 1 minus answer. Okay, this is the probability that the interval contained unknown population parameters. Okay, the y reason 1 minus answer. It will show the probability that the interval contained unknown population parameters. So it means that for the left part, for the left answers, right? Answers, the sum of two regions in both sides, right hand side and left hand side, is will be the probability that interval do not contain parameters. Okay, so sometimes the values in here, here's some common value for confidence interval. Maybe confidence interval equal 99, 95% or 90%. Okay, so for some time in here, so let I argue when the confidence interval, when I use 95 confidence interval, 95 confidence intervals. So in that case, what is the value for answer? Class, when the confidence interval is 99%, so what is the value for answer? Tu Hương, it is not the correct answer. Okay, yes, it is 1%, right? Or 0.01, okay? But in in that case, answer equal 1%, answer equal 1%, answers equal 1%. So it means that the reason in both sides will be equal 1% over 2, right? You have to divide this into two same parts, right hand side and left hand side. So the areas into left hand side and right hand side will be equal 1% divided by 2. And after that, you have to find the values in here, z. Okay, z of answer over 2. So it is some step you can use to define the values of z answer over 2 in the formula. Okay, so for other values,
mình hợp với cái máy iPad với cốc ấy.
Lê An, can you mute your microphone? Lê An. Okay, so we can completely find the interval, right? Okay, so in this line, I show you the example, right? This is an example when confidence level. I know the values of answers equals 0.1. So what is the value for confidence interval here, class? What is the confidence interval here? Which denoted by CI. What is the confidence interval here? .8? Really? Okay, thank you. Confidence interval denoted by 1 minus alpha. So it's equal 90% or 0.9. In this case, 90%. Okay? And after that, you can find the areas. The areas alpha over 2 is the areas, or is the probability. You have to divide it by 2 because you have to divide this into 2 tables of the shape. So the probabilities in here will be equal. There are 2 ways. Actually, you can find the values in from the left hand side. This is the probabilities when z smaller than minus z alpha over 2 equal. What value here, class? Probabilities when z smaller or equal to minus z alpha over 2. What is the probability here? What is the areas of the region in the of the shaded region in the left hand side? Okay, thank you. This is 0.05. Thank you very much. Or you can find the positive value here, right? Which is the probabilities when z smaller than z alpha over 2 equal 0.95. Okay, this is the same. You can search the values from the positive or negative sign. And after that, look at the table number 1. Okay, so right now we could like to find the values of z. We could like to find the values of z when the probability is equal 0.95. Okay, so look at the table. The name of this table is standard normal distribution, right? We focus on the values of z. So now, because we know the value for probabilities 0.95, so you have to search in the rectangular part here, because we could like to find the values of z. We know the values of probabilities or the area, so we have to search in the rectangular region. So for p 0.95, what is that value? 0.95 here. Actually, we cannot find exactly value 0.95, but in here you can see that there are 2 values nearly closest to that value, 0.95. Is it 0.9495 and 0.9505? Okay, so because that values stand between that 2 values. So can you get what is the value for z? The first plate after decimal point and the second plate after decimal point. So can you get what kind of values of z here? What is the value for z here, class? The probabilities stand between that 2 values. So what? Okay, Vương Thu Ngân, if you choose the values of z equal exactly 1.64, if you choose the values of z equal exactly 1.64, So the probabilities in here is not 0.95. This is 0.9495. Yes. Okay, thank you, Thu Hương and Tuấn Hưng. Yes. Because the value 0.95 is stand between that two values, so you have to take the values of the second decimal point. The second after decimal point is between that two values. So the value for Z in this case is 1.64045. Okay. Z equal 1.6445. Any questions in this part, class? No. Okay. So let me give you another example for you to practice the way to find Z. Okay, for the next line, actually this is show you the step by step to find the values of Z 0.05, right? Now, when you look at to the form of interval extend, interval extend from h bar minus these answer over to standard errors to h plus these answer over to standard errors. So can you get the factors affecting the interval weight? When you look at to the intervals, the form of interval, can you guess what is the factor affecting interval weight? Okay, the first one is its confidence interval, right? From Phương Thảo. Because confidence interval is real, is it the value for, it show you the value for Z, right? So for the first one, maybe the level of confidence 90% or 95% when you change the values, so it will affect Z. For the next, the sample size N. See, when you change the values of and, so the weight, the first point of the interval or the end point of the interval will change, and the data's variability is measured by population standard deviation, right? So you can see that when you look at to the form of the interval, you can guess, you can define the factors, right?
Em ơi, cô quay lại slide trước đúng không ạ?
Yes. Yeah.
Vâng ạ.
Okay, so in the figures, I show you the shape, the pictures of sampling distribution of mean, and in here is the mean of X bar, mean of the sample, right? Sometimes we denote by mean of X bar, so we know that this is the mean for the sample. Okay, we have the example here. We have the example in here. So I'm going to spend 1 minute for you to read, to take a look about the example. And after that, what is the keyword in here, class? Actually, it's not the long word problems, because it show you all the information here. The first one, n equal 25. This is a sample size. Sample size equal 25. And the value for mean of sample. Okay, we have 95% confidence interval. And we know the standard deviation of population. And we know that the population is normal distributed. See? So I highlight all the keyword in this problem. Okay, so what we do in the first step, class? What we do in the first step, you can look at your slide and give me the answer. What we do in the first step? No one? No. For the first step, we have to check the assumption. Okay? This is for the first step and for the second step. Okay, for the first step, we will check the assumption. Population standard deviation is known. In this case, standard deviation equal 10. So we know the value for the standard deviation of population. Okay? And for the second step, because in here, we have that information. Population is normally distributed. So we don't need to apply the central limit theorems. In this case, we know that values. Population is normally distributed. So after check the assumption, you can define the confidence interval estimate. Okay, because the confidence interval is 95%, confidence interval is 95%. So we know that 1 minus alpha equal 95%. So what is the value for alpha here, class? Yes, 5%. 5%. So we could like to find that value, right? 5%. So it means that 2.5% from the left, 2.5% from the right, and 2.5% from the left. So you have to find that value, z of alpha over 2 or minus z alpha over 2. So right now I will spend time for you to search for the values. 0.025. Now you have to find the probabilities when z, right now I could like to find the positive value. So the values of z in here have to smaller than, greater than which value? To show that the probability is in here is 2.5%. This is z answer over 2. Is this 5% over 2? Now, one more time to repeat the way to use the table. For the standard normal distribution, we know the areas in the left hand side, right? But right now I could like to find the areas in the right hand side. Z is greater than. So you have to convert it into which formula? Is equal to 1 minus to what? Do you remember? Okay, thank you, Ming-Chen. Or the other way, you can find the probabilities when z is smaller or equal to z answer over 2. So because the areas in the right hand side equal 2.5%, right? So the areas in the left hand side, the y reason will equal 100 minus 2.5%, right? 100 minus 2.5%, which is equal 97.5%. 97.5%. So right now, can you search in your table, in your tables, in your standard normal distribution table? Please help me to search for the values of z, where the probability is equal 97.5%. Point 975. Okay, we have exact values here. So in this case, what is the value for z class? The probability is equal 97.5%. So the value for z will be equal exactly 1.96. Okay, sometimes it shows you the value for probabilities, or sometimes it gives you the values that you have to estimate or find the average between any two values. Okay. Okay, so this is some steps. I show the answer. H bar equal 50. See, H bar equal 50. Z answer over 2 or answer is equal 5%. So Z is the answer over 2. Standard deviation equal 10 and the sample size equal 25. After I can find the values of Z, I can replace all the values and find out the interval. And the conclusion in here that the mean, the population mean will belong to the interval from 46.08 to 53.92. It is a conclusion. You can estimate the interval which the mean the population belong to. Okay, so it is a way we can find the confidence interval. when you know the standard deviation of population. Any questions, class? Can I move to the next slide? Okay, thank you, Nhật Ánh and Tuấn Hưng. So when develop an interval estimate of population mean, we usually do not have a good estimate of the population standard deviation either. So in this case, we must use the same sample to estimate both mean and standard deviation of population. This situation represent the standard deviation of population unknown case, sigma unknown, okay? So when S is due to estimate, because we don't know the value for sigma standard deviation of population, so we have to use S, right? The sample standard deviation. S is used to estimate sigma, so the margins of errors and the interval estimate for the population means are based on a probability distribution known as the T distribution. We have the new one, student T distribution. Although the mathematical development of the T distribution is based on the assumption of a normal distribution for the population, so we have sampling from research so that the T distribution can be successfully applied in many situations where the populations divide significantly from normal. Okay, so in this case, the population is exactly normal. We cannot apply central limit theorem in here because the population have exactly normal distributed. Okay, and look at to the formula of confidence interval. In this case, X bar is a sample mean. We will learn the way to find the best value after this line. S is this sample standard deviation, and here is a sample size. We know some notation in this formula. Okay, so right now let's move to define the T distribution, student distribution. Is it letter T? Okay, so here is a formula. Here is a formula to convert from normal distribution X bar into the T distribution T, letter T. If we are sampling from a normal distribution, the T statistics have a sampling distribution very much like that of these statistics. This is mouth shape, symmetric, and mean equal exactly 0. This is for T distribution. And the main difference between the sampling distribution of T and Z is that the T statistics is more variable than the Z. So the T distribution is a family of similar probability distribution with a specific T distribution depending on a parameter known as the degree of freedom. For the degree of freedom, the T distribution with 1 degree, which is denoted by df, 1 df is unique, as the T distribution with 2 df, with 3 dfs, and so on. So as the number of degrees of freedom increase, the difference between T distribution and the standard normal distribution become smaller and smaller. So the figures, look at the figure in here. The black curve is for standard normal distribution, and the round and blue one show the T distribution. So the figure shows T distribution with 5 degrees of freedom and 13 degrees of freedom, and their relationship to the standard normal probability distribution. So note that a T distribution with more, you can see that with more, when the degree of freedom increase, more degree of freedom exhibit less variabilities and more closely to resembles the standard normal distribution. Okay. So note also the mean of the T distribution is 0. And see the degree of freedom when it's increased, so the shape become smaller. It come close to the standard normal. The difference become smaller and smaller. And when degree of freedom is 20, for example, so the difference between that two curves become smaller and smaller. Okay. Okay, so look at the slide here. The names, you can find the tables for T distributions, student T distribution table in the table number 2 in your textbook. So when you look at the table here, there is two main parts. The first one is just a column for degree of freedom, and for the second one, it shows you the areas in the upper tables. So the difference between T distribution and standard normal distribution is that for T distribution, it shows you the areas in the right hand side, but for standard normal distribution Z, it shows you the areas in the left hand side. Okay, so this is the difference between that two distributions. T distribution will show you the areas in the right hand side, but for Z standard normal distribution, it shows you the areas in the left hand side. So the areas in the upper tail will show you here. This is the value for areas here. The second rows, it shows you the areas in upper tails. Here is the area 10%, 5%, or 2.5%, and some values in the rectangle show the values of T or the values in the horizontal line. Okay, so the formula to find the degree of freedom. Degree of freedom equal the sample size minus 1. So we have the sample size equal 3. So the degree of freedom in this case equal 2. And I showed you the values, I give you the values of alpha. Alpha equals 0.1 or 10%. So the values, the areas in both tails, in two tails is 0.05. So can you find the values in this point? Z T's of alpha over 2, where the degree of freedom equal to. Can you search and give me the answer for that value T, where the degree of freedom equal to? Degree of freedom equal to. First of all, you have to search the degree of freedom, and in this case, it's equal to. Okay, thank you, Chen Ming. And the areas in the right hand side, or the areas in upper tails, is 0.05. Okay, thank you, Quang Dat. So the value for t is in here is 2.920. Okay, so I have one more questions for you. If I have one more example for you, I will show you the sample size equal 4. Confidence interval is 80%. 80%. So can you help me to find the values of t and for over 2 and df? Okay, I will spend 5 minutes. Is this enough for you? 5 minutes for one of you. After 5 minutes, I will check randomly. You have 4 minutes left. Okay, I see 3 answers here. What about the other one? Đào Minh Tùng. Đào Minh Tùng. Are you here? Phùng Dũng. Hoàng Minh Châu. Hoàng Hùng Bi. Are you here? Nguyễn Đức Huỳnh. Nguyễn Văn Hải. Okay, so I need a person to volunteer to show me step by step to find the values of t here. Trịnh Thảo. Write things in the next lectures if we still learn by these methods. Online, I will ask you to turn on your visuals, your cameras. Okay, thank you, Hồng Hạnh. First of all, we have to find the value for degree of freedom, which is equal to n minus 1. N minus 1. And in this case, is equal 3. And after that, confidence interval. Confidence intervals is 1 minus alpha equal 80%. So it means that the value for alphas will be equal 20%. And the value for answer over 2, the areas in the upper tail will be equal 10% or 0.10, and the degree of freedom 3. So the value for t in here is 1.63h. Okay, so the answers in the mock test correct. Any questions in the part class? Is there any questions? When you search the value for t distribution. Okay, thank you, Nia and me. Okay, so we have the example for unknown standard deviation of population.